Okay, so I want to be clear that this is an intro level talk. So if you're like an existing Kubeflow user, this is probably not the talk for you. And there are many other fine Kubeflow talks that we'll show you. But if you're new to Kubeflow, that's really great. We're really glad that you're here. And we would also love your email addresses so that we can contact you, not spam you, because we're in Europe and you have laws about that stuff. But we can contact you in accordance with local regulation to let you know when the Introduction to Machine Learning with Kubeflow book is ready. Our co-author bailed on us yesterday, so we didn't manage to write it at the pool, but I'm feeling really good about writing it tomorrow, realistically over the next few months. Oh man, clicky button stopped working. Where's your mouse? Okay, cool. Okay, cool. And so here are some of your other options for Kubeflow talks. Some of these are in the past, but you know, if we don't scare you away from Kubeflow, definitely check out some of these. If you're more experienced with Kubeflow, these talks could also be a better fit for you, because this is, as mentioned, intro. So yeah, we are building cross-cloud machine learning pipelines with Spark and TensorFlow, and it's going to be super fun. It's designed to be a beginner level talk. We'll tell you who we are. We'll give you a little bit of background. We'll talk about what Kubeflow is, some of its core components, and then we'll talk about how to build a cross-cloud ML pipeline with Kubeflow and Apache Spark and TensorFlow. And that's a lot of things to get through. So we're going to cover it kind of quickly, and we're going to give you links to go deeper into any of the parts that you're particularly interested in. So I'm Holden. My preferred pronouns are she or her. It's tattooed on my wrist, which is really convenient in the mornings. You know, when you're a little hungover and you're just like, who am I? Where am I? It's really great. I'm a developer advocate at Google. I work on open source big data, which means that my employer pays me to work on things that we give away for free. It's pretty great. I love my job. I'm on the Apache Spark PMC. And this means that in the Spark project, it is really, really hard to get rid of me. It's like tenure, but I don't get paid. So it's like a really shitty tenure. And I've worked at a bunch of other companies. Trevor and I work together at IBM. It's super fun. If anyone's really interested in open source, I've started doing code review live streams, and they're also recorded and posted on YouTube. And you can sort of see some of the other parts of the open source process that you might not have experienced before. And I think they're kind of neat, because I do them mostly in Apache Spark, which is something with thousands of contributors, and so it's a bit of a different feel than sort of like a smaller open source project. If you've got any feedback, I have this link here. I'm always trying to do better, and I would love anyone's feedback, except about like my style. Like, that's not changing.
Hello? All right, cool. Does this work?
Yeah, the clicky thing works now.
Okay. My name's Trevor Grant. I'm from Chicago. My preferred pronouns are he and him. I do various odd jobs around IBM. We're still in flux about what exactly it is that I do there. I'm also a PMC on a few Apache projects, Mahout, Streams, the community development. I'm also a member of the Apache Software Foundation. There's an IoT track coming up at ApacheCon North America that I'm helping. There's also going to be one at ApacheCon Europe, which might be more relevant to everyone here, but I'm organizing the North America one. So please submit. Oh wait, no, the CFP's come. Please come to Las Vegas in September and see our IoT track. You can find me all around the web on the common handle of Rockin' Trevo, blogs, websites, GitHub, LinkedIn, you name it, Rockin' Trevo. Been doing it since high school. They say you can't make up your own nickname, and they're wrong. So in this part of the talk, we normally tell several jokes about Kubeflow, or not about Kubeflow, about data scientists, and we kind of rip on them for a little bit. This is a 35-minute presentation where we're normally used to having maybe 40 to 50 minutes. So we're going to skip through them really quick. I recommend that you check out some of our previous talks, and you can get all of our funny jokes about all of these things. GPUs, we make fun of stuff, shout out. This is a pretty good graph. Take pictures of this if you guys are taking pictures of slides.
Yeah.
This joke travels.
So if you know nothing, you want a lot of GPUs. And once you learn that you only need linear regression, life is pretty chill. And then you realize that you can't use linear regression to find cats, and then you need a lot of GPUs. Sorry, I just couldn't skip that joke. I just can't.
We also make fun of Kubernetes for the purpose of the talk, magic and shipping containers. As a bunch of Kubernetes novices in here, I'm sure you would all agree that's pretty much accurate.
I guess I
data scientists in their natural habitat, coding in a coffee shop on their MacBook, and then data scientists deploying to production. And wait for it. Oh, there's the bugs.
Features, Trevor.
So without further ado, what is Kubeflow?
I think this one's me.
Yep.
I don't need the microphone. That's good. Okay. So is there anyone here who believes that Kubeflow is magic with shipping containers and TensorFlow? Okay, cool. When I do this at Strata, there's a lot of people who are like, Kubernetes, Flow, TensorFlow. But no, it's not just that. It's a whole bunch of other things. It is the Hilton breakfast buffet of machine learning platforms. Do you have, no, people don't stay at Hilton's here. Okay. Okay, Karau buffet. Do you not have buffets? Okay. Whatever. So it's a collection of different things that we can choose from, and some of them go together very wonderfully, and other ones, like the shrimp and the mango, when you wrap it in ham, maybe starts to taste a little funny, right? So we can add all sorts of things together, and we can build something really wonderful, but we can also build a monstrosity, which if you've had a job, you've seen a lot of those before. And so here's some of the components that make up Kubeflow. There's everything from doing pipelining, there's tools to do data preparation, there's tools to serve your jobs like TF serving and Selden, and then there's tools to move data around and all of those fun things. And you can train many different kinds of models. We're going to talk a little bit about TensorFlow models, but not too much. And you can do anything in Python, but that's kind of a hack because by you can do anything in Python, it's the same sort of thing as like, well, we gave you a Docker container. You can do anything. But there's CRDs to do special types of models easily and quickly. And so that's really awesome. And we also have tools to do data preparation as of Kubeflow 0.5, which was released 2 months ago, maybe 3 months ago. Before that, shell scripts, very, very lovely shell scripts. You can use Spark, you can use Pachyderm to copy data around, you can use pandas, and if you really enjoy writing shell scripts, you can still, of course, write shell scripts to do your data preparation. And then once you've got your data ready, you've trained your model, you can persist it somewhere. Right now, we don't really know where. You can put it in a cloud object store and call it a day. I like _2 final _real. That's how I know which model is in production. More seriously, you'll want to use another tool for model tracking, and unfortunately, it's more or less on you at this point. And then when we can serve it, we can use Selden Core. If you like using things that explicitly tell you not to use them in production, you can use Flask. You can also use TensorFlow serving, or if all of those options sound like not a lot of fun, you can of course always write your own custom logic on top of it, because why do something that other people have done when you can do it different? Okay, cool. So how does this fit into the data science ecosystem? And so research is really great. And if you can convince your boss that the deliverable insights of your job don't actually need to deliver anything, that is great. Keep that job for a long time. On the other hand, at some point, your business users will come to you and be like, I heard you had this really good model. I would like to use it. And while you can only stall them for so long, at some point they'll make you put it somewhere that you can use. And Kubeflow aims to solve this problem of allowing us to put our models somewhere useful in production, but also allowing these to be repeatable so that our business users aren't coming to us every month and being like, hey, can you update your model? It's still recommending Hannah Montana. That's just not cool anymore, right? And then like you having to go and find untitled _7.ipython notebook and being like, I think 7 was the good one. 8 was a little rough. And thank you so much, people in the front row. I'm so glad. I'm imagining that you're not from Europe. So thank you. Anyways, and so Kubeflow helps us bridge this gap from lab to production. It helps us get our machine learning pipelines repeatable, able to run, and semi-reliable with less shell scripts than before, and not a guarantee. Don't sue me. Okay, cool. So hopefully we didn't scare you away from the idea of using Kubeflow. I think I keep going here, right? Yeah, I think so. Okay, cool. So what are we going to do? Oh, right, and we have very important fresh cat pictures. And actually, not just fresh cat pictures. This is a cat video shot today?
Yesterday.
Okay, cool.
But very fresh.
And if we take a look, those are two cats. Two cats. That's how you can
Twice as good as the last time we showed this video.
Yeah. So fresh cat pictures. So first thing that we need to do is we need to step away from our keyboard. Oh, thanks, Trevor.
Just background.
Background. Okay, so we're going to step away from our keyboard and we're going to think about which tools we want to use, right? And this is important because if we just sort of run straight into it, we can end up building that like cream cheese shrimp mango combination by accident, right? And if you don't know what your data looks like, thankfully, you can use Jupyter to do some exploratory analytics on your data and figure out what's going on. And you want to go ahead and do that first before you just start building a TensorFlow model, because TensorFlow sounds cool. Okay, and so maybe you're like, you know what, Holden, that sounds great, but I just want to build whatever model everyone else is doing because, whatever, exploratory analytics, not cool enough. I'm not going to get a new job saying I wrote some Jupyter notebooks. I want to build some TensorFlow models. And for you, I say, yeah, okay, we can go ahead and do this. There are two separate entry points into Kubeflow. There's the shell script, which is old and deprecated, and there's the Go program, which is new and doesn't work. Or it works, but like it broke yesterday, I think, in the workshop.
It works.
Yeah, okay, it works, and that's where more things are going to go. And you can see here that there are multiple platforms supported, and that's one of the important things, right? We could generate something without any platform specifications, just deploy it on raw Kubernetes, or if we're going to deploy on top of GCP, we can generate a GCP Aware project or a Microsoft Aware project, and it'll do a whole bunch of other setup work so that we can use things beyond just the normal vanilla Kubernetes for us. And we can generate this and apply everything. And then because I work on Spark, regardless of whether or not you actually use Spark in your pipeline, you should install it. And this is because there's a tracking thing that you can opt into, and you should definitely opt into the tracking and install Spark so that it shows that Spark is useful. Because, I like my job. Okay, cool. And so what do we get with the chef's recommended pairing? We get Jupyter Hub to do our exploratory analytics. We get some TensorFlow job stuff. We get TensorFlow serving. We get PyTorch. We get some hyperparameter tuning tools. Oh, yeah, okay, and we get something to route our requests. We get a nice web UI, and we get some pipelines. And the pipelines are really just Argo with magic. And it turns out when you add magic on top of anything, you get a nice UI, but also sometimes it doesn't work. And it sometimes doesn't work. Yeah, that's true. Okay, cool. And so this is you. Do you remember the joke?
There was something about a cat, and this somehow ties back into the pipelines. And I don't.
Dude, we practiced this yesterday, man.
I know.
Right,
whatever, I got the laugh, so I'm just gonna drive forward with it. What are those pipelines? So again, they're just a thin wrapper over Argo. You get a nice directed acyclical graph. I can never say that right either. But it's a bunch of Docker containers, and each performs its own special little function. This is a picture of what the pipelines look like, and it's kind of a simple coin flip and then print a number out.
Yeah, so about as high quality as most machine learning pipelines, I'd say.
Yeah. One that maybe makes more sense for an actual machine learning deployments here. Your data comes in, it gets validated, pre-processed, there's some training, you're deploying a model. There's lots of different ways you can do this. Read the docs or read Argo. But it's a little out of scope for our introductory talk to get too deep into it. Be aware that pipelines are a fun feature that will be working soon.
No, they work. They just sometimes don't.
There will be more dependable soon.
Yeah, that sounds good.
Using Spark. Oh,
yeah, this one's me. Yeah, okay. I'm Spark.
All right.
Cool. Okay, cool. So How many people here have done any machine learning with Spark? Ah, it's a good number of people. I'm very sorry. How many people here have used Spark? That's slightly more people. OK, cool. So that's lovely. So this is great because I don't have a lot of slides about Spark. But that's cool. So in pure Spark, we can do our data prep. We can pull data from all kinds of different sources. We can even pull it from multiple cloud vendors, right? Like if we have some data in Redshift and we have some data in GCS and we have some data in Bigtable, we can query all of those and pull them together. We can join and augment our data as needed. And there's a whole bunch of tools to do feature preparation in Spark. This is really nice. We've got things to do filtering for like kicking out invalid data. We can fill in invalid data with other values to a degree. And if you want to see some code examples of how to do this, I've got something in a project called Frank the Unicorn, which in case you can't tell is a demo project based on its name, but it shows you how to do like sort of a separate data preparation stage, which we'll just run in Spark. And then once we've done our data preparation in Spark, we want to use TensorFlow because TensorFlow is cool, and because Spark's machine learning libraries look somewhat like tumbleweed going across the Serengeti desert thingy. Anyway, so Spark's machine learning libraries are not getting a lot of love currently. And so while the feature preparation is really cool, it lets us do distributed feature prep, you know, if we want to use modern things, we're going to end up wanting to use other tools downstream. And so we can use things like TensorFlow on Spark to just keep doing our TensorFlow job inside of our Spark job. Or we could just be like, you know what, Spark, thank you very much for your feature preparation. Please save the results to my favorite object store, and I'm going to kick off another job and keep going from there. Although that is kind of slow because we have to write everything to disk and then read it all back in. And so we're going to talk about why, even though the first option sounds really good, it's not. Because happiness is an illusion. OK, cool. So PySpark, which is the Python interface to Spark, which is what we need to use to get at TensorFlow, uses pickling, which is Python serialization. It's not very good, but it exists. And not only does it use pickling, it uses pickling from Java, which indeed you can do poorly. It uses sockets, Unix pipes, and JSON. And I don't have a funny image for JSON because JSON is not funny. OK, so it's Python interface to Spark. It's more or less built with those components. And while it works surprisingly well, it has some surprising, or actually, I guess not surprising, it has some pretty obvious performance challenges if you think about what happens when you glue components together in these ways. And so this design more or less looks something like this. We use Py4j, which is kind of slow, but it doesn't matter because there's not too much data on sort of our master node, which does all of our coordination. And our worker nodes, here I just said pipes. In reality, we do use a combination of pipes, sockets, and files, because why pick one thing when you can pick three? And I think we might actually do something special if you deploy on Windows, but I've never done that. And so we've got our workers, and they're going to copy all of this data from the JVM to Python. Who thinks this design sounds fast? Yeah, OK. Thanks, Trevor. OK, cool. So yeah, this means that when we do this, we do our feature prep inside of Spark. And yeah, we're not saving our data to disk, but we are having to copy it from the JVM into Python. And this is really slow. Also, incidentally, if anything goes wrong, you're just screwed. The error messages are completely unintelligible. You'll get things like Python stack traces wrapped in Java stack traces wrapped in, I think it goes Python, Java, Python is the normal sort of stack trace collection that you'll get. And then you'll get between 0 and k times 2, where k is the number of workers, copies of the same stack trace, maybe. But they may not be different, and we perform no deduplication for you. So that's great. Oh, and incidentally, if you go over any memory limits, we do nothing except just fail. Your containers will just get deleted without any notice. Cool. So maybe you're looking at this and you're like, Holden, this sounds bad. Why are you telling me how to do this? I don't want to do this. Okay, well, let's continue to do bad things. So TensorFlow on Spark from the wonderful people at Yahoo, I believe. I should have checked that last night. Anyways, it lets us run like our TensorFlow graphs really easily on Spark data. And this is more or less what it looks like. And we look, if we're training, go ahead and call cluster.train. And this is really convenient, really nice. Go ahead and run our training job. It's just really slow, and if anything goes wrong, we're completely screwed. But maybe we can make this better. So there's a vendor who I no longer work for, so I tell you to not trust them. But to be fair, don't trust any vendor. Like, we all want to sell you things. Although, to be fair, this is open source software, so sell is a very fuzzy concept. And there's this graph which implies that if we used Apache Arrow with Spark, it could be 242 times faster. And if you believe that, I wish I had your optimism. It's not. But we can use Apache Arrow to make the data copy from Java into Python much more reasonable. It's a lot faster. We still have data copy happening, right, because we're going from JVM heap to Python heap, but the formats are no longer just like completely different. We're not having to translate the format, so it's a lot faster here. Not 242 times faster, in my experience. Maybe 20%, but I could understand. Maybe they lost a few decimal places when they were making their marketing materials. And it's actually pretty easy to swap this kind of code around. So inside of Spark, we'll see things like spark.catalog.register function, and that's just saying like, here's my special Python code that I want to call. And if we want to use Arrow now, all we do is we use this thing called a pandas UDF, which is actually not pandas UDF. I don't know why we called it that. But we use this thing called a pandas UDF, which is actually an Apache Arrow UDF. And we give it the same function, more or less, and we give it a return type. And we can do this with TensorFlow on Spark. The core part of TensorFlow on Spark right now calls for each partition, does its magic, except instead what we'll do is we'll put this thing in here, and we'll give back a bunch of zeros because we forgot to support returning nulls. Sorry. But it's OK. We'll just return a bunch of zeros, and now our code will be up to 242 times faster. Yay! Realistically, 10 to 20%. OK, cool. And now our design looks somewhat like this. Yay! OK, well, I thought that was cool. Now, incidentally, if you try and do this, you may run into the exciting opportunity of getting to manage your Python dependencies, because Spark looked at that problem and went, how about the vendors solve it? Which is the traditional answer to any hard problem, specifically hard problems which are not fun to solve in open source. So if you're running Spark on Kubernetes, we actually, it's pretty reasonable. You can specify a custom container, you can bake your requirements into that container, and then everything is happy. If your data scientists are happy doing that, you have much more systems background data scientists than I tend to work with. I think we need some better tools here, but at the very least, giving them a shell script to produce a container for them to run on is a lot less work than the alternative, which is running on top of Yarn. And OK, I want to be clear. These stars mean please don't sue me. And I do not necessarily.
Or fire us.
Oh, yeah. No. Like, I'm on an H-1B in America. Like, I do not want to have to find a new job and try and transfer a work visa. Not in today's climate. OK, and these are not the official positions of any of these companies. These are the results of what I've heard customers have been told from interacting with them. And so people running on top of CDH have told me when they go to Cloudera and are like, hey, I want to run like TensorFlow and have all of these dependencies, to make that work. They're like, have you considered the many benefits of buying a software solution from someone else? Preferably with a markup on top of it, I'm pretty sure. I don't think they mentioned the markup part, but it's good. Google were like, that sounds lovely. Have you heard of shell scripts? And it turns out when you tell data scientists this, they kind of, the best case scenario, they go yes and leave the room. And IBM says, call Cloudera.
Got out of the Hadoop game a long time ago.
Good call on that one. Good call on that one. Turns out managed Yarn, I don't know why this isn't liquor. Anyways, but thankfully, Kubernetes folks, your life is easier and you can avoid having to maintain 200 different Anaconda distributions. Or 20, I don't remember. Okay, cool. Often when I tell people how PySpark works and how Spark works with TensorFlow, they're like, Holden, the system sounds terrible. What should I use instead? I'm here to tell you, don't worry, everything is garbage. Now, different garbage, different, but not better. No. Very similar designs, some slight differences. Apache Beam has tighter integration with the TensorFlow tooling. However, it doesn't work particularly well with the Python versions, which is what you need for the TensorFlow tooling outside of Google Cloud. So it's not super portable. They're working on it. But also from a data copy perspective, it's not any better. They use Protos instead of Arrow, but that's just like saying that I run on diesel instead of gasoline. It's not a big difference. Or you can look at this entire mess and be like, you know what, Holden? All of those things sound like an exciting opportunity to buy a support contract. You know what I'm going to do? I'm going to run my Spark job and save the results to disk. And if you decide to do that, I'm very happy for you. I think that's probably the best answer to put something in production in the short term if you are not planning on quitting your job.
Next person's problem.
Yeah, no, it's great. Someone else will get to update it in 6 months. Okay, cool. So the other part of this talk is cross-cloud. Presumably you're here because that sounded fun, but just in case you're here by accident, we'll tell you the benefits. Or Trevor will, I think, yeah.
Yes? Yeah, there we go. Sorry, I'm messing with the AV people by always flipping my mic on and off. So there's going to be a why and a how to cross-cloud. And this is the part of the talk where everyone, about 90% of the people down in the vendor hall, I just shoot them right in the back, including both of our bosses.
Thankfully, they don't watch our talks, as far as I know. So if you know this guy at Google, what's my Eric? Oh, Eric in the Google Seattle office. Now's a good time to hit pause if you're watching the recording, Eric. It's a great talk.
My performance is not tied to my talks, so I can do whatever I want.
You're lucky.
Clouds are becoming commoditized, and that goes, well, yeah, there's cloud, and that's because a big part of Kubernetes. Kubernetes is Kubernetes is Kubernetes. I got to my hotel lobby on maybe Monday night, and another IBMer was down there, and we were both hanging out at the bar, and he was wearing an IBM shirt, and I'm like, do you work for IBM? He's like, I do. And so we kind of got to chatting, and he's like, yeah, but our Kubernetes is the best. And he was a young kid, and I'm like, aw, you're so cute. But, and that joke carries because Kubernetes is Kubernetes is Kubernetes, and that's great. So in theory, the IBM Kubernetes, the Google Cloud Kubernetes, the Azure Kubernetes, they're all the same. They are getting there. There are better and worse implementations currently, but they're all getting to be, just the same. So you should be able to lift and shift your jobs. That's very, very good for consumers because you can just lift and shift your jobs, and that's bad for producers for reasons we're going to get into soon. And you can help make this happen a little sooner, and we'll also have a slide on that. So, commoditization of clouds. To kind of dig into this a little more, commoditization is when there's no discernible difference in the product. Examples of commodities, if you're not familiar with them, gasoline, corn, soybeans, oil, things that are traded like commodities. My undergrad is actually in economics, so this is a fun time to use my undergrad degree, which you don't always get to do in your real grown-up job.
Yeah, I know.
Perfect competition. Producers of commodities are price takers. I grew up in the central United States. These are some Iowa farmers. They can sell their corn at whatever the local merchandiser is paying that day. Or they can hold it and try to, maybe it'll be worth more minus the cost of the storage. Anyway, that's too far into commodities. That's what commoditization does. And it's good for, again, it's bad for, producers. But it's great for consumers because if you have jobs, you can flip on your computer in the morning and say, whose Kubernetes is cheapest today, and move. And you're already kind of starting to see this happening, and the way that the cloud companies are fighting back is by having these like in very, very convoluted pricing agreements where like, oh, but it's never quite the same size. Sometimes you get more cores or less memory per node. And they do that on purpose so you can't apples to apples compare them. But you're already starting to see us kind of slide down that ramp.
These are Trevor's views, I just want to be clear.
These are Trevor. That's fair. So we're getting that thing. If you think of like a gas station, I've noticed in Barcelona you don't have like multiple gas stations on like the same corner, but in the US that's a very big thing where you'll have 4 gas stations right there and they're all charging the same price because if somebody's 2 cents a gallon higher, nobody's going to go to that gas station, they're always going to go to the other one. And you're going to start to see that with Kubernetes and cloud, which is great. This is the opposite of vendor lock-in. That's what the cloud vendors have been doing since the 70s.
I don't think they sold clouds in the 70s.
They sold computers, though.
Okay.
Well, we did anyway.
Touche, touche.
It's monopolistic power. There is only one DB2. I'm picking on DB2 because I'm more likely to get fired, not sued by IBM. But everybody, all the computer companies do it. Oracle, Teradata, Google, AWS, name a cloud company. They're trying to lock you into their proprietary solution, or they have been. We're starting to see a little bit more vendor neutrality, and that's what you want. You want a vendor agnostic deployment because that's going to save you the most money. It's a little bit more expensive on the upfront, but will save you money later. How can you help make this faster? By designing apps that are designed to be vendor agnostic. And then if there's a problem with the vendor agnostics because you've got enterprise contracts, throw a hissy fit at the sales rep and be like, why isn't this working when it doesn't work?
Yeah, to be clear, neither of us in sales, so
yeah.
like that's why we tell you to blame someone else. Yeah.
How? So there's 3 main ways. What does the cross-cloud mean? You can train on multiple clouds. This is difficult and
questionable benefit to train on multiple clouds at the same time.
A more reasonable way would be to train on one cloud and serve on multiple clouds, because just like there's commoditization, but GPUs will have different prices than, let's say, memory and CPUs. So your different rigs are also going to be differently priced. And then you have portable pipelines, those things I was talking about earlier. And why those are important is because you have reproducible science. That's the not fun part about data science that the data scientists never want to do. You have reproducible experiments that can, in theory, be ran here and there. And when data scientist 1 leaves and data scientist 2 comes on 3 months later, they can pick up data scientist 1's I was going to say junk, but you know, research.
Quality code.
Yeah. Do data gravity, we're short on time. I'll talk to you more about it in the hall. Train on cloud, oh, that was, okay, cool. I've already talked about these things. Portable pipelines. Putting the science back in data science.
Yeah, this one.
Oh, we're good, okay. Yeah.
I'll talk about it. Okay, cool. So another thing that I think is a relatively real use case is making your pipeline actually cross-cloud. That's like, I train here, at the end of my training, I go ahead and I upload it and I serve it on other clouds. Okay, 2 minutes. Okay, hacky S3 copy final to py.sh. That sounds like a really quality shell script that has some inline Python inside of it. And it turns out that, yeah, so if you click on this link, you can go take a look at this. Essentially, add an extra pipeline stage at the end of your pipeline where it takes the model that's in the persistent volume that was produced and uploads it into S3 or whatever the right cloud object storage is. And then you can run your pipeline on KF Cloud 2, and except instead of training, you'll have a stage which downloads the trained result from the first pipeline on Cloud 1. And we've got 2 minutes left, so serve it with Selden. Great.
Thank you for the tweet, Selden.
Yeah.
If anybody else wants us to give us some shout outs in our slides, make sure to tweet our talks just ahead of time.
Cool. And so if you're interested in sort of playing with any of these things, here are some code labs that I think are relevant. So the code labs are things that are much better organized, but they don't show you how to do cross-cloud. And then there's this random GitHub repo, which has a readme.md file. And the tutorial is about the quality of what you would expect. But there's also a video of me trying to do my own code lab, which is hilarious. It does not go well. But it does finish. And we've got 30 seconds left. So, OK, there's some downsides to using this. It's O.5 software, but here's the DIY workshop. Let's focus on you should buy our book. It does not exist yet, but that should not stop you from giving us your email addresses. And with that, there is no time for a 20-second demo. We'll be out in the hallway to take any questions people have, so we don't get in the way of the next talk. Thank you all for coming.
Thank you very much.